I'm going to kick off here and get started. Thanks for making it up here after the lunch keynote. I know it's half a mile between there and here, it seems like running, so I appreciate y'all making the trek. This session, as the slides tell you here, is called don't want to key off my friend here, but we're going to make a serverless skill for my little friend that we'll talk about here. Again, ask you to please rate sessions and ask questions, and we will be trying to answer those right here at the end. My name is Chris Munns. I am a senior and the lead developer advocate for serverless at AWS. I'm technically part of the Lambda and API Gateway product teams. Based in New York, I've happily been able to speak at GOTO Chicago before, as well as another one of the events, GOTO Copenhagen. And primarily what I do is go around and help our developer customers understand what it is to build serverless applications. And it just so happens that serverless skills are, I think, one of the best things that you can build. Let's kick off here with my friend. Alexa, open GOTO Chicago.
Hi, what can I help you with?
Let's start the presentation.
I'm ready. Are you sure you won't mess up like in Copenhagen?
Yes.
Good luck. That was embarrassing last time.
Yeah. So in Copenhagen, they had me do a no slides, just code talk. And I had my friend here with me connected to the venue. You had to log in interactively to get on the Wi-Fi. And so I had my phone with international data, Wi-Fi turned on, tethered to an Echo in this dungeon of a room. And it didn't go so well. So hopefully today we'll do a little bit better. And just real quick, I'm going to silence my friend's wake word. It's easier to talk about Alexa when you don't have to worry about her waking up and saying things to you. So why are we here in this session today? Voice is becoming ever present in how we interact with the world around us. For millennia, humans have interacted with voice with each other, but now we're interacting via voice to things around us that normally wouldn't be able to interact back. And we've seen this progression in technology of starting with everything from trackballs up through keyboards, up through web interfaces, up through now touchscreens, which are incredibly commonplace. I was just talking with some folks during lunch about how I have a 20-month-old, and now anytime that he sees a screen, he assumes it's a touch screen because all he has seen is iPads and iPhones. And so the idea that there's a screen that isn't touchable and interactive, he didn't understand it. Voice is becoming just as commonplace. So we've got some interesting data points out there. This is from a company called MindMeld, and what they have here is a stat from 2014. About 10% of all search traffic was voice-based, and that was a couple of years ago. And basically what they had in the data points that they had collected was that over 50 billion voice searches per month were happening, and they expect that to be over 200 billion by 2020. That's a lot of vocally interacting with the world around us. And so here at Amazon back in 2014, we first announced the availability of our little friend here, Alexa, via a couple of devices that we've had. And since then, her popularity and the capabilities of Alexa have grown incredibly quickly. There's over 30,000 skills today in the Alexa Skills Store. Just back at reInvent, our user conference for AWS in end of November, beginning of December, we announced something called Alexa for Business. And there's a lot of things that you could do with Alexa now, interacting with the world around us, whether it be physical devices, whether it be the things that are capable inside of Alexa, whether it be your car, whether it be your TV, whether it soon be other appliances at your house, turning on and off lights, things like that. There's lots of things that we can do with Alexa and with voice services. So how does Alexa actually work behind the scenes? It's actually pretty straightforward, even though there's a lot of very complicated technology that is being masked. Essentially, this is kind of the big picture topology of what we have. We have some sort of a device that runs what's called AVS, or the Alexa Voice Service. The Alexa Voice Service then is basically what's represented inside of this cloud here. When you interact with that, it goes back and interacts with a backend, which we'll be talking about here today, and hopefully generates a response. And so how this really works, the terminology that we use is that there is signal processing that happens inside of a device that has AVS enabled on it. So this here is an Echo Show, or an Echo Spot, sorry. Has a nice little screen. I can actually touch this and do things with it. We've got a couple other devices that have screens and then many that don't. But what happens is when I say Alexa, that is the wake word that is configured for this, everything that after that becomes basically an utterance that becomes, it's called an intent. We'll talk about that here in a little bit, which will kick off ideally a skill, which will interface with the rules that I've set up, talk to my backend, generate what are called requests and responses, and then give a response back to my device. And that response could be audio, that response could be video, it could be a still image, or it could be it taking an action, such as like turning on and off the lights. In that case, I'm not going to expect Alexa to say, I'm turning on and off the lights, I'm just going to expect it to do it. And so pretty straightforward kind of logic loop here again, right? You as a user say something to the device, Alexa, do blah, blah, blah. Alexa takes that, processes it, sends a request off to your backend. Backend does what it needs to do, spits back a response to you, says it, displays it, or takes the action. Really pretty kind of straightforward request-response flow. Now, one of the key technologies behind Alexa is a service that we have at AWS called Amazon Lex. There's actually two services that are key to what Alexa is. One is called Lex, the other is called Polly. So what Lex is a natural language understanding service. Basically, you can use this to create your own chatbots, to create your own audio bots. And again, it's kind of the core foundational understanding technology, translating speech into text and deriving what it is that you're trying to do based on that. So as an example of this, there's a couple of kind of core concepts that we have. One is utterances. This is basically the things that you say to a voice service to tell it to do something. So you see here, for example, I'd like to book a hotel. I'd like to make hotel reservations. Can you help me book my hotel? I want to book a hotel in New York City. These are all phrases that we're saying that we need there to be some sort of interpretation of by a service so that it can understand what it is that we're trying to accomplish. Now, what this lends itself to is a concept of having what we call slots of information. So going back to the example of booking a hotel, there's a bunch of information that I need in order to successfully do this. Where do I want to book my hotel? When do I want to check in? When do I want to check out? There might be all sorts of other things that I might care about here. And so what a voice service like AVS does is it allows us to do what's called slot elicitation. Basically allowed it to converse back with me to find and gather all the information that it needs in order to complete what it is that I'm doing. So I don't necessarily have to say all at once, Alexa, I'd like to book a hotel in New York, check me in on this date, check me out on that date. That's a whole lot to have to say, and I'd have to know that exact phrasing. But instead, I could start with a very basic kind of intent of what I'm looking for, and then build off of there. So a way to kind of visualize this is we see here that I'd like to book a hotel. And so I say, book a hotel in New York City. So I am giving it some information. What will happen here is that behind the scenes in the Alexa voice service, actually powered by Amazon Lex, is going to pull apart the words that are inside of this. So it sees book a hotel in New York City. It then takes that and based on language understanding, knowing how people actually speak, turns those into what are considered intents and or slots of information. It still has to figure that out a little bit. And then from here, what can happen is it can understand that, okay, your intent is to book a hotel. In order for me to complete this intent, I need to fulfill these slots of information. And this is, again, as a developer, I've told it what those slots are. And so now Alexa can come back to me and ask me questions to fulfill basically the gathering of that slot information. Let's take an example like order a pizza. I could say, Alexa, I'd like to order a pizza. It's going to come back and say, what size? What toppings? Is there anything else you'd like to order with it? All of the questions it is asking back to me are so it can attempt to gather slots of information. At the end of it gathering enough information for the base amount of slots that it needs to complete what it needs to complete, then what it can have is a confirmation. Are you sure that you would like to order this large pizza with pepperoni? And I can say yes or no, or potentially reply in other ways. And then at some point, since it's gathered all this information, it can actually go and place that order for me, and then come back and spit out a response that says, okay, the pizza's on the way, okay, I've booked your hotel. And again, Amazon Polly is a service that does text to speech, so kind of the inverse of what Lex does. So it's kind of broad, big view. There's a lot of other things that Alexa itself can do. So again, Alexa is a combination of a couple of core technologies, but then it also has this massive AI capability built on top of all sorts of knowledge that it has consumed from many different places. You can get knowledge from Wikipedia, from internet searches, things from history that it has basically digested into the wealth of knowledge that Alexa has. So Alexa is a bit more complicated than just Alexa and Polly, There's quite a lot that she's capable of. So what's really awesome is if you have one of these devices, it's actually super easy to create what's called a skill. So again, a skill is a thing that Alexa can do. So when I say, Alexa, order me a pizza from Domino's, that is a skill. Alexa, check my bank account with Capital One, that is a skill. Alexa, turn on the lights in the living room, that is a skill. And so you could very easily extend this yourself with one of these devices. So when it comes to an Alexa skill, there's basically two core components. There is the user interface, essentially what is on the Alexa voice service side of a skill, and then there is the backend that is going to fulfill the conversation that I'm having. And so going along with all of the stuff that powers Alexa, at AWS we have a service called Lambda, which I'm going to talk a little bit further about here. And what the Alexa team says is that Lambda is basically the best way to build a skill. Technically, you could build a skill and host it on anything that is an HTTP or HTTPS server, but Lambda has some benefits to it that fit really well into making it a good place for hosting a skill. And we'll talk about that a little bit here. And so as a developer, you can basically just start in two different places. One is the Alexa Developer Console. The other is the AWS Developer Console. And so we're going to have to go into both of those places today in order to create our skill. And so I'm going to take a break here real quick to kick this off, and then we're going to come back and talk a little bit further about Lambda. Alexa, open GOTO Chicago.
Hi, what can I help you with?
Talk about the demo.
Alrighty. Creating an Alexa skill is a two-part process. You need to define the interaction model and then provide a backend. Today, Chris is going to start by launching the Lambda backend via Amazon Web Services CodeStar. CodeStar is going to provide a strong starting point for us to build the backend for a new skill. It will give us a continuous integration and delivery pipeline, a code repository, an IDE using Cloud9, and a few other nice things like a dashboard to see all the activity for our backend. It can connect to repositories in GitHub and provide you with ways to connect various IDE products if you wanted to. He could do all of this by hand across the various services, but why do all that work? CodeStar comes with a number of pre-built templates for launching all sorts of applications, but Chris is going to select an Alexa skill powered by Lambda as the base for our demo. Then he selects the repository type and configures Cloud9. It takes a few minutes to launch all of this, so we'll come back to it later. Back to you, Chris, to walk everyone through the interaction model for new Alexa skills.
Alexa, thanks.
You're welcome.
Cool. So I very quickly, if you were following, went and fired up a CodeStar project. It's going to take a couple minutes for it to create all the things that I have, so we're going to come back to this. While we're waiting for this to happen, let's go ahead and take a look at the Alexa Developer Console. So I'm logged into the Alexa Developer Console. I have a couple of skills that I've played with in the past before. But let's go ahead and create a completely new one. So let's go ahead and name my skill Chicago Cab, we'll call it. And we're going to create this as a custom skill. Awesome. So out of the gate, it's going to kind of give me some basic things. On the left-hand side here, you'll see what are called built-in intents. So we have cancel, help, and stop. Pretty straightforward things that we might want to use to help inside of our Alexa skill. First thing I need is my invocation name. My invocation name is essentially the wake phrase that my Alexa skill is going to use. So I had named this Chicago Cab, so let's go ahead and continue to call this Chicago Cab. And so what I'd end up saying here is, Alexa, open Chicago Cab. Alexa, start Chicago Cab. Alexa, ask Chicago Cab. Those are all various things that I could do as part of this. And then I'm going to save this model. Now, the next thing that I need here are intents. And again, these are basically the things that I'm trying to have this Alexa skill do. So maybe in this case, what I want to do is get a ride. So let's go ahead and name this get ride intent. And so now what it's going to want is sample utterances. This is actually maybe one of the trickiest parts about Alexa skills, is defining enough sample utterances that when you go to do what's called build an Alexa skill here in a moment, it will actually take those different phrases, apply a bunch of machine learning to them, and help you build kind of a wider array of the words that could be used to actually invoke this intent. Again, what we don't want to have is a skill that has such little flexibility into it that a user has to remember an exact, say, 5-word phrase every single time in order to complete an action or kind of kick off an intent. So again, this is called Chicago cab. So maybe sample utterances is, I'd like a cab, get me a cab, tell a cab to pick me up, call a cab for me. To get a cab. And we can save this. Cool. So right with what I have right now here, the very basics of this is that the idea here is I would say, Alexa, open Chicago cab, I'd like a cab, I'd like a ride. Now what I'm probably going to want is it to ask me some questions about this. So for example, I'm going to want it to ask me, well, where are you and where do you want to go? And so what we have then, again, is this concept of slots. Right? So we know at least 2 different slots that I'm going to want. Where am I, and where is it that I'd like to go? So let's go ahead and create a new slot. We'll call this current location. And then what I have here are various different slot types that can basically help me do filtering and making sure that I'm entering in something that's right. I wouldn't want, for example, to say, Alexa, get me a cab, and it says, where are you? And I say, dog. That may not be a valid address. I wouldn't want it to say, 42, and have it understand what that is. So what we have here are a bunch of pre-built slot types for all sorts of different things that are out there, and it's a pretty wide range of things that you could find across different languages. Again, stuff from popular culture, movies, athletes, sport teams, other things that you might want to match against. I can also go and create a completely custom slot. So I can create a slot that contains potential words that fit my exact use case. And I'll show you an example of that here a little later. So in this case, I am going to just have it do cities for me. So this will validate against US cities. And then we're going to do desk location. And we are also going to give it the exact same type of slot type. Cool. Now, the last thing that we're going to do is we're going to want some sort of a confirmation. So what this again means is right before it's going to go and call that cab or send an API call to get that cab for me, it's going to say, are you sure that you want to do this? And so what it can say to me is, are you sure you want to go from current location to desk location? And in this case, it's just going to look for a yes or no, more or less. And I can give it multiple examples of this. Cool. So I'm going to save this now. And I'm going to see if it will let me build it without the backend being here. Cool. All right, so this is the most basic aspect of what we have here. We've defined a interaction model that includes an intention. That intention has a couple slots that we would need to fill, and then we have a confirmation question that we would get asked to confirm that we're doing what we need to do. This is basically all that we really need to do inside of the Alexa console to enable a conversation skill basically to exist just like I described it would work. What we would need from here now is the back end. But before we get to that, let's actually go back and go into just a little bit more slides. Cool. So I had mentioned that from the viewpoint of the Alexa team, Lambda they feel is the best thing to back-end a Alexa skill, and actually a very large amount of Alexa skills are backed by Lambda. Now Lambda falls into what we call serverless computing product. If you've been down to the Expo Center, you've seen the AWS booth. We're actually here from the Serverless product organization sponsoring all of the GOTO events this year. So really working on getting out this message. But what is serverless? So it's kind of a hot term in the industry. It means a lot of things to a lot of different people, but for us at AWS, serverless means basically kind of 4 key criteria to how we categorize products and say what kind of does fit in the box versus what doesn't fit in the box for what serverless is. So for us, it comes down to there being absolutely no servers to provision or manage. This means no physical, no virtual, no containers even that you would have to yourself take care of and care about. There's nothing below your code level. It scales automatically with usage. So in the case of an Alexa skill, we should never have to think about capacity planning. If I, for some reason, manage to get a skill that is so amazing and it's used by everyone and it's getting hundreds of requests per second, I should never have to think about capacity planning for what that is. Or if I was building an API that was processing thousands of requests per second, I shouldn't have to think about how to scale that. And so our serverless products all fit that. Never having to pay for idle is another one that is actually one of the key differentiators between what makes a technology serverless and what it doesn't. So typically when you're building backend infrastructure for applications, one of the things that you pretty much have to do is always have at least one of something. So always you have to have at least one server, always have one container, always have at least something there, so when a request comes in, it can answer it. Now, in many organizations, what you end up having to do is capacity planning. So we know that at some point there may be X amount of requests or X amount of users. We want to make sure that we can always handle that. That typically requires you over provisioning infrastructure, and this leads to a lot of waste in the industry. In fact, Gartner says that less than 20% of IT infrastructure is actually utilized. Most of it sits there, never getting requests, never doing anything. So never paying for idle is a very big change in terms of the cost model perspective for serverless. And then lastly, availability and fault tolerance built in. So we don't want to have to think about having n+1 of something so that we have failover, we have resiliency that we have to control. In the case of the service products, this is going to be done for us. So at the core of this world for us is a product called AWS Lambda. It's part of the product team that I am part of. And so Lambda is a compute service where you write code and you send it up to basically to the service. Today we support 5 primary languages: Node.js, Python, Java, C#, and more recently Go, which came out in January. And then what happens is we have some sort of an event source, in this case the Alexa voice service, which is going to send an event to Lambda, which is going to fire up your code. It's going to process that event. Maybe it has to talk to a database, maybe it has to talk to another API, maybe it just has to have logic inside of itself. And then it's going to go and reply back potentially to that service or do whatever it is that it needs to do. And the idea here is that you're taking a larger application and decomposing it into smaller parts. So unlike a more traditional application design where you might have many components inside of a single application, in the world of Lambda, you typically are taking a large application and having separate functions. So an example of this is if you had an API that had, say, 20 different capabilities or 20 actions inside of it, each of those actions would align to an individual Lambda function, as opposed to you just having a single code base there running. Now, functions are pretty straightforward in terms of what they have to look like. Again, you provide your own code. We don't have any sort of kind of control over what it is that you do and write. There are some kind of basic constructs that you have, though. So one is that we have a concept called a handler. You have to tell the Lambda service where your handler is in your code base so that we know where it is that we have to start or invoke your code. And then there's basically 2 other things that we provide to you that you can use in your application to do whatever it is that you need to. The first is the event context. This is basically the information that's coming in from your invoking source. So in the case of an Alexa skill, this is going to be information about whatever it is that the request that has been going into it. In the case of an API call, it could be the information coming in from the API. There's a number of other things that are there. And then we provide something called the context object. The context object is essentially information about this Lambda functions environment, how it's configured, where it can find logs, a number of other aspects about it. But these are basically kind of the 3 core components to a Lambda function. So we can write a Lambda function, we can write our code. And what we want to do, though, is make it really easy to deploy these Lambda functions. Now, we have CLIs, we have web consoles, we have all sorts of other tools that you can use to do this. But back about a year or so ago, we launched another tool which is growing very quickly in popularity to help with it. So we have a tool called SAM, AWS SAM. If any of you have come by the Expo Center, we've been handing out SAM stickers all week. If you didn't get a chance to grab them, go down there after this and grab some stickers. So SAM is the squirrel mascot for serverless, but it also stands for Serverless Application Models. And so what this is a template-driven system for deploying serverless applications, and it provides a number of different capabilities in terms of simplifying what it takes to basically structure and configure all of the underlying services at AWS. And just about 2 or 3 weeks ago, we actually completely open sourced the engine for this. So we're really pretty excited about the community involvement there. And so what a SAM template looks like is what you see here on the screen. And my apologies, given the lighting and the size of the screen here, it might be a little hard to read. But essentially what we have is some configuration information about our Lambda function, where the code lives, what my handler is called, the version of the language that I'm using. It's called a policy, essentially the permissions that this function has. So can it talk to certain databases? Can it talk to certain other services, and so on? And then we see an event structure. And here, in this case, the event structure is for an Alexa skill. And there's actually nothing else that I have to do to configure it for that. Down below here, we see what's called a list table. This would create a simple DynamoDB database, which is a NoSQL data store that we have here at AWS. And actually, I read through it without my highlighting slide. But again, pretty much just 3 sections to this. And so this roughly about 16, 17 lines of code is all that you need to configure your Lambda function, configure it to be accessed by Alexa, and give it permissions to talk to other backend services. Also within the last year, we announced something called SAM Local. And so what this allows you to do is actually to test your serverless functions locally on your own laptop. And so you could use this to basically mock out the Lambda function, test it, and ideally be able to debug and quickly iterate on top of your function. So given all of this, previously, what my good friend did was talk to you about how I launched a project with what's called AWS CodeStar. Let me now go back into CodeStar and walk you through kind of the rest of what it is that's going on here. So CodeStar is a service that, oh no, where did my, there we go. Cool. CodeStar is a service that wraps around a number of our development tools. And so what it does is it gives me a whole bunch of capabilities. One is that I can actually set up a team-based project. So if I have other developers in my company, whatever my company in this case might be, something that I'm hacking on or something for an actual business, I can actually add them to get permissions to everything that's inside of this project. I could also do things like configure issue tracking. I could plug into Jira and stuff like that. I'm going to close this out here. Now, other things that it did. So it gave me what's called a Cloud 9 environment. This is our IDE product at AWS. And we'll come back to this here in just a second. It also shows me my application endpoints. This is actually really key for Alexa. So in here, it has the endpoint for my Lambda function. I'll try to make this a little bigger for folks. It also gives me links to the developer console and the documentation. If I scroll down a little further here, on what is your right-hand side, you'll see a bunch of boxes that have a green stripe down the side. This is actually a view into what's called a code pipeline, which is a continuous delivery service that we have that allows me basically to automate from check-in all the way out to production deploy of my code. And so this pipeline has 3 steps in it today. It has a source repository that I'll commit my code to. It has a build step that could hypothetically compile my code if I was using compiled language. However, it also packages up my code for me. And then it has a deploy step, which will go and take my SAM template and use it to deploy my serverless application, in this case, my Alexa skill. I can see other information about my application here, such as the activity. So if this was a service that was getting a lot of traffic, once it's up and running, I would get information here. I can also see my commit history for the code. So, and then lastly, I have a wiki panel that I can come in here and I can edit this and say things like, this is my wiki, and use this to share information with my team. In this case, I'm just going to remove this. And so I can configure this and change what's in here and all that kind of good stuff. Now, the other thing that I did was I pre-selected a template, which in this case was for an Alexa skill. So let me go here to my IDE and go ahead and look at the code that I've already started with. So we've got inside of CodeStar a number of different templates for different types of applications, APIs, again, Alexa skills, web applications, all sorts of different things that exist inside of that. Now, what it's done is basically created for me an environment with code inside of it. And so inside of this, I have an index.js file. This is the code for my Alexa skill. Down at the bottom here, you can see that I've got a terminal window, so I can do things like interface with Git and write the code for my Alexa skill. So give me 1 second here to actually configure Git on this host. And then I will go and configure this here. Okay, good. And then just like in any other browser or any other terminal window I could go and see the status in Git for my code. Let me try to make this a bit bigger for folks. Sorry, 1 second here. Can folks see the terminal window on the bottom a little more clearly? I know the lighting here makes it a little harder. Folks kind of see that now a little bit? Yeah, okay, cool. So inside of the code that's inside of this pre-built skill example for me here is kind of all the basic things that I need to get started with an Alexa skill. So it's going to go and include the Alexa SDK. Now this is going to include the V1 SDK. The Alexa team actually just last week or the week before released a V2 SDK for Node.js. I haven't had a chance to get too deeply into it, but it should simplify life, and actually reading into it, it looks like it does simplify a bit of what I'm going to show you here today. And I know I've got just about 10 minutes left here. Now the other thing that I have here are language strings. So today you can use Alexa in a number of different countries. And so what it can actually do is be country aware to where it is and provide phrases and sayings back to you based on the country that you're in. Now the example that I chose before was a facts example. So what it has here is different facts about the solar system, I believe. I actually don't care about any of this stuff, so I'm just going to go and delete all of this for now. And so for any of the British folks in the room, sorry, I'm not going to provide any unique translations for you today. I'm going to get rid of all of these facts. And my apologies to any of my German friends in the room as well. Just for the sake of ease today, I'm going to get rid of the German language things here. Okay, so my skill name here was called Chicago Cab. Get rid of this. I can have a help message here. So what I'm going to do for my help message is put something a little bit easier. And so what I have here is, again, just basic kind of string replacement inside of this. Now I'm going to zoom all the way down to the bottom of this code example and show you real quick here the handler. So I had mentioned before that the handler is basically the entry point that Lambda uses into your code base. So the event handler for Alexa skill is really pretty straightforward. Basically just goes ahead and creates a new Alexa handler. For security reasons, I could assign, or I could paste in my app ID so that Alexa will only invoke this skill with the app ID that I've configured. Hypothetically, you could share backend code between skills, but I can lock it down if I wanted to. It's going to register that I have these language strings. Again, I just got rid of the Great Britain and German strings, so I just have the American English ones. Then I'm going to register handlers, which I'll talk about here in a second, and then execute it. So this is what would happen when an event came into my Alexa skill. Now up ahead here, what I have are a bunch of the basic requests intentions that this skill can handle. So I have a launch request. This is kind of a default inside of a skill. When I invoked the skill before, when I first got here, I said, Alexa, open GOTO Chicago. That basically called a launch request. Then after it, when I said to it, let's start the presentation, that was one intent. When I said, talk to us about the demo, that was another intent. And so then below here, what we have are various intents. And then we have some Amazon default intents to help with various aspects. So what I am going to do is I am going to change this so that I'm going to get rid of this get fact. Actually, get rid of this fact function. I'm going to leave my help intent. And then I am going to basically tell it that what I want it to do is to play some of the messages that I have here. So up here for this launch request, what I'm going to do is tell it to say my help message, basically how it knows to help me. And we'll start with just that. I'm actually going to get rid of this middle one here. Okay. So I have, for the most part, stripped out all of the things that were originally in here that made this a get fact skill. What I've done, again, is stripped out kind of the phrases that I don't need. I've set up my basic launch request. I'm going to have it say that when I open up this app, Chicago Cab, it's going to say my help message. And typically, actually, what I would want to do is have it do a prompt for me. So 1 second here. I have a help message. Good. Actually, we're going to do it. Sorry, 1 second here. Let me do it this way. So what I'm changing here inside the launch request is I'm going to make it, when it first starts, be able to say, hi, I'm here to help you. How can I help you, more or less? And so this is, again, all great developers, copy and paste. Cool. So what has this done here? So again, we see launch request. When I go to open this skill, what it's going to do is I'm combining here the help message and the help reprompt. And I'm telling it that I want to emit an ask. So Alexa has different ways of pronouncing words, pronouncing phrases for you. In this case, it's going to pronounce something as a question. So there's going to be certain pronunciation that it does for words that align with this. And then what it's going to do is prompt. So it's basically going to assume that there are things that I'm looking for it to do in terms of an intent. So let's go ahead and save this. And what I can see here is I have changed my index.js. Oops. I'm going to commit this. And I'm going to push this. I know I just had the 5-minute sign, but I started about 5 minutes late, so can I just get another minute or two? I know I had the 5-minute sign, but I started a couple minutes late. Can I just have like just another 2-3 minutes? Great, thank you. Just because I know things are going to take a little bit of time. Okay, so in my IDE here, I have committed code. If I come over here now and look at my pipeline, I refreshed it after I picked it up, but what it's doing is it's going to now kick off the build of my code. So it's now going to take my code from source, send it to build, and then deploy it. So what do we mean for build in this case? Well, if I come back into my IDE and I open up this file called the buildspec.yml file, this is basically the instruction file for a service called code build. And so code build can be used for compilation, unit testing, packaging, linting, all sorts of stuff that I want to do with my code. In this case, the base code build.yml just does some really straightforward stuff. It's going to install the AWS CLI, because I'm going to need that to deploy my Lambda function. It's going to run npm install. In this case, I already have a package.json that came pre-configured to install the Alexa SDK for me. After it does that, then it's going to call a command called AWS CloudFormation Package. This is basically going to take my Lambda function, any related code that I have here, bundle it up for me, and put it up into an S3 bucket so that Lambda can grab it soon after that. And then down at the bottom here, it basically tells it that you're going to package this up with a zip file, and then there's an output YML file that comes out of this. So now I can actually here, back in my IDE, see that my build stage has kicked off. I can actually go and basically watch this happen in real time. So the build history is down here. Now, because it's doing this all for the first time and I don't have, in this current configuration, dependency caching turned on, it's going to pull in the Alexa SDK, it's going to pull in the AWS CLI and all the dependencies for that. So that can take a minute or two given kind of NPM packages and how long they take. While that's happening, I'm actually just going to go back to the Alexa console and configure it so that I can talk to my function. So this real quick here, I went into the Lambda console, and what I need to get from here is the ARN, or essentially the Amazon resource name for this Lambda function. And this is so that I can tell the Alexa console, or the Alexa skill service, where this backend exists for this function. So I'm back here in this console. I'm going to go to endpoint. I'm using a Lambda function, and I'm going to set this as the default. Now, maybe I had a Lambda function that I was running in multiple places around the globe. I could actually specify backends specific to those regions for performance or potentially differences in code reasons. In this case, the default is good enough for my example here. And so again, I'm going to save this endpoint. Cool. So I'm going to come back here to intents, and once again, just save my model, and then go ahead and build my model. All right, while this is doing this, I'm going to, just because of time, jump to another example. Basically what's going to happen now while this is finishing up is this is going to go and deploy this Lambda function for me. Oh, maybe I did it already. Where's the time? No. No, that was the initial deploy. So it's probably just maybe catch up. I'm going to go and show another example again here just for the sake of time. So this is the code base and the pipeline and everything for the skill that I used when I first came in here. Again, when I come here, Alexa, open GOTO Chicago.
Hi, what can I help you with?
Exit. Okay. So if I come back in my skills here, I'm going to quickly show what this skill actually looks like. And hopefully we'll be able to show this other skill doing something. So inside of this skill, I just have a couple of intents. So I have my start talk intent. So we saw before me say, kick off the presentation, let's get started, et cetera, et cetera. I also have my demo talk intent. Again, this was when it talked through the things that I was doing initially with CodeStar. And then I have one more intent, which I'm previewing here, but we'll see our friend here say goodbye at the end. Now, if I come here to the start talk intent, you'll see kind of below here, if you look on the side, there's something here that says yes or no. What I actually have here is a custom slot that I've created called yes or no. And if I come down here, oops, I can see that what this is I've defined a slot that I'm looking to get information from, and I've defined what it is that is considered acceptable for this slot. So in this case, you see, yep, yeah, I do, yes, please, you know it, nope, I do not, no, thank you, etc. And so again, just these kind of key phrases is going to help give Alexa an idea of what should be considered an acceptable phrase for this skill. Now, if I go and look at the code for this skill, looks pretty similar to the one that we were just looking at. What I have up top here is my strings. So I have the strings that were spoken. I have the strings, for example, for the demo talk. And there's some interesting things here. So before, when we had, in my intro, you heard Alexa say a curse word. In this case, I'm able to basically tell Alexa to interpret that as a curse word or as an explicative. In that case, it bleeps out the word. And much like iOS correction, I have ducking here instead of the other word that would have been bleeped out. You can see also down below other ones here, like I had it say alrighty. There's other things that it can say. I can tell it to pause for a little bit, so there's a break down here. There's all sorts of other things you can do with the voice service itself of having it, say, spell out words, treat things as numbers, treat things as telephone numbers. You can change the pitch. You can change how quickly it says something. You can make Alexa whisper. You can make it shout. There's all sorts of phrases there. If I come down here now to the actual skill, we actually see things that look pretty much just like the code that we had in the example that's currently compiling and building. So I have a launch request. And this launch request has speech output. It has a prompt message. What's a little bit different down here is that you'll see that this says ask with card. If you can read that, I've highlighted that there. Now for devices of Amazon's creation and others that actually support the Alexa voice service that have a screen, the things that show up on the screen are referred to as a card. And you can have both static images, you can have videos, and you can have text that shows up. Now in this case what happens is it's actually going to display the text that is being verbalized out there and can show an image in the background. Unfortunately with the Echo Spot, the image that I chose doesn't properly render there. When I go down to the start talk intent. So when I do hear Alexa, open GOTO Chicago.
Hi, what can I help you with?
Start the presentation.
I'm ready. Are you sure you won't mess up like in Copenhagen?
Stop.
Goodbye.
Okay. So right there where it basically came back and asked me, are you sure you won't mess up like you did in Copenhagen? That is it attempting to fulfill a slot. And so the second line that we see here where I have var equals var filled slots equals delegate slot collection. What I actually have down inside of this code is another function here, which basically what this does is it more or less says, can the Alexa service tell me that all of the slots that I'm expecting to be filled have been filled? If not, the Alexa voice service needs to go and ask questions of the user until it has all of those slots filled. Now in this case with this Alexa skill, all I had was this one slot that's basically yes or no. And so it said, okay, there's not been anything entered as part of this. I'm going to go and prompt the user for it. And then if I replied yes or no, it would take action based on that. In this case, it's just looking for a yes or a no. And essentially, it will continue to do this back and forth until all the slots have been filled. In this case, there was just this one slot. And then from there, after it basically fills all those slots, then it will come down and run the next line in this, which is basically telling me good luck. And this is where it bleeped out what it said. So let's come back to my other CodeStar environment here, just see where we are. OK. So inside of this, my code, my Lambda function is now deployed. We had the other skill, which was the Chicago cab skill. And now this is where we really tempt the demo gods. Alexa, open Chicago cab. Okay, that didn't work. Alexa, start Chicago cab.
You can say get me a cab or call a cab for me.
Get a cab for me.
There was a problem with the requested skills response.
Cool. So that's actually something we would expect to happen at this point. OK, so what happened? So just like we had configured this for here, essentially I used the invocation word, which was open Chicago cab. I then basically, as part of that, told it that I wanted it to get me a ride. So I used one of the phrases here, one of the sample utterances for the get ride intent. And then what happened after this, however, is I don't have inside of my code currently a handler. Where am I? I currently do not have a handler for that intent. Now, had I had a handler for that intent, it would have actually looked just like this here, where I would have done a delegation for slot collection. It would have gathered those slots for me. I could have then processed that information and essentially done something with it. So we got almost there. Cool. So we didn't get entirely through this, but hopefully you got to see here we created an Alexa skill. We then created a backend for that skill. We got the backend to do a little bit of something in terms of reading off the text that I had put inside of the skill. We didn't get, unfortunately, to the prompting for slot fulfillment. But hopefully you got a little bit of an idea of what it is that goes into doing this. Just in about 45 minutes, we got it to kind of kick off and build all of the stuff required for doing that. It's really fun, kind of exciting stuff. Again, my day-to-day is more on the Lambda side of things, but I've been really fascinated and excited about what you can do here with my little friend. I have, again, a 20-month-old son. He walks around the apartment that I live in, and when he sees an echo, he goes, because he can't say Alexa yet. But when we do see Alexa, we say things like, Alexa, bark like a dog. So little kids love this shit, really. You got to try it on them. It's a lot of fun. One other thing we didn't get a chance to talk about, at AWS, we just launched this about a month or so ago, this thing called the Serverless Application Repository. There's a whole bunch of skill examples in there. People just kind of post these things up. It's a great way to share and learn, but tons of places to basically grok code and move forward. You can read more about the serverless stuff on aws.amazon.com/serverless. I believe it is developers.alexa.com for the development console for Alexa.
Sorry, I'm not sure about that.
Great. My name's Chris Munns. You can find me Munns at amazon.com or at Chris Munns on Twitter. Alexa, open GOTO Chicago.
Hi, what can I help you with?
Say goodbye.
Au revoir. Bon voyage. Thanks for coming. Have a great rest of your day.
Thanks. So thank you for coming. Really appreciate it. Hope you've learned a little something. Please rate this session. I know that I'm eating into the next people's time, so I'm going to come out back and answer questions. But thank you all. Enjoy the rest of the day.